Hello my dear students, welcome back to my new class. This class is for students of class 9. In class 9, the chapter expansion is going on. First chapter already we have completed, and today I will start the second chapter of expansion. In the second chapter of expansion, there is the identities for a plus b whole cube. Okay, so we have to derive identities for a plus b whole cube. Okay, a plus b whole cube, a minus b whole cube, all these things. Clear? So first write down a question that expand this, write as a question. Okay, so we'll simplify it. What is the value of it? We are going to find out that. Solution: a plus b whole cube. This can be written as, we can write a plus b whole square into a plus b. Since we have learned already the expansion or expanded form or simplified form of a plus b whole square, that's why we will use that. So a plus b whole square, in the place of a plus b whole square, we can write a square plus 2ab plus b square. Okay, in the place of this, and a plus b is left, so a plus b. Now we have to use distributive property, okay, and expand it. So first we will consider the first term, this a, and we will multiply with this second factor, that is whole a plus b. Okay, and secondly we will consider 2ab and multiply with this term a plus b, and third we will consider b square and we will multiply with this. Okay, so first I am considering a square. So this a square, if we multiply this a square with a plus b, then a square into a will be a cube, and a square into b will be a square b. Okay, so a square into a means a cube, plus is there, and a square into b means a square b. Since these two are different variables, so we can't multiply these two. We have to keep it in this form. Next, now consider 2ab, and similarly again multiply the first one and second one. So if you multiply 2ab and a, then it will be first sign plus 2. If you multiply a and a, then it is a square and b. Okay, and this, that means 2ab and b. So 2ab into b what? 2ab into b means here b into b square, and so ultimately it will come 2ab square. Understood? So plus 2ab square. So this complete for second term, and now for third term, that means for b square. B square with this whole term. So b square with first one, it will be b square a and b square a. B square a and ab square, these two are same thing. Okay, so we will write here ab square, it will be better. Okay, now for the second, so plus into plus, b square into b means b cube. So this complete the expanded. Now we have to simplify it. So if we simplify it, then we get a cube. Here 2 times a, 1 times a square b, and here 2 times a square b. So if we, since these two are like terms, why these two terms are like, here the literal coefficient a square b, and for the second term a square b. Here 2 times a square b, and this is 1 times a square b. So total 3 times a square b. So 3a square b. So these two terms simplified. Now for this term, 2ab square plus ab square. Since we have to add here, so this is ultimately 3ab square, and lastly b cube. So this is the simplified form or expanded form of a plus b whole cube. Okay, so finally we get a plus b whole cube equals to a cube plus 3a square b plus 3ab square plus bq, and this is an identity, and you have to memorize these identities like a plus b whole square. Okay, you have to memorize this identity. Similarly, if you expand a minus b whole square in the place of a minus, if you expand a minus b whole square, then you will get, I am writing here, sorry, a minus b whole cube. In similar way, you will get for a minus b whole cube equals to, these two are basically same, just sign will be changed. Sign will be in alternate form. If first term is positive, then second one negative, then third one negative, positive, positive, negative, positive, negative, in this way. Okay, so I am considering first term positive, a cube plus, so it will be minus 3a square b. Since this is minus, so it will be plus 3ab square. Since we have considered here plus, so it will be minus b cube. So this is the expanded form of a minus b whole cube. That means this is the identities for a plus b whole cube, and this is the identities for a minus b whole cube. Understood? So you have to memorize these two identities. You can proof of this second one you can do by yourself. Okay, similar way. Clear? Now you have to derive one more thing for a cube plus b cube. Look at the board. So now we have two identities. We have a plus b whole cube equals to a cube plus 3a square b plus 3ab square plus b cube, and another one is for a minus b whole cube. A minus b whole cube equals to a cube minus 3a square b plus 3ab square minus b cube. Okay, this line equals to this line. If we write it by the change of their sign, then it will remain unchanged. Okay, that is, I am considering the left hand side into right hand side and right hand side to left hand side. So if we write this term in right hand side, then it will be a cube plus 3a square b plus 3ab square plus b cube equals to a plus b whole cube. Understood? Now we are going to simplify from this line. We are going to simplify for a cube plus b cube. Okay, since our target is to compute the value of, or to simplify for a cube plus b cube, so we will keep a cube plus b cube into left hand side, and we have to consider remaining all the terms in another side. Okay, so we will keep here a cube plus b cube and consider all the terms into that side. So already in this side, already in right hand side, a plus b whole cube is there, so write it, and we have to consider this term and this term into another side. So if this is plus 3a square b, so if we consider this term in another side, then it will be minus 3a square b, and this second one will be minus 3a b square. Now simplify it. So our target is to compute a cube plus b cube. We have just we have to simplify it, then we will get exact. So a plus b whole cube. If we take common from last two terms, 3ab will come common. Then write 3ab. Then the left term in the first term will be a. See, 3a square is there. Already a have taken. So only one a will be there and b has taken. So minus b, a plus b. Since we have taken, if we have minus common, so it will be plus. So ultimately we get a cube plus b cube equals to, therefore a cube plus b cube equals to, we get an identities that a plus b whole cube minus 3ab into a plus b. So you have to memorize this result also. This is one more important identity, and we have derived it from what? The first one, a plus b whole cube. So this identity you have to memorize. Clear? Similarly, for second one, you can also in similar manner you can derive the identities for a cube minus b cube. Okay, I am deriving. Look at the board. Okay, just write it into converse way. Then a cube minus 3a square b plus 3a b square minus b cube equals to a minus b whole cube. Similarly, we are going to compute for a cube minus b cube. So a cube, b cube keep in this side. So a cube minus b cube, and consider all the terms in another side. Then it will be a plus minus b whole cube plus 3 square b minus 3a b square. This. Now a minus b whole cube. Here you have to take common 3ab. So it will be a. For the first term already 3a square b is there, and we have taken common ab. So a is left, and for the second b is left. So finally we get what? Finally we get a cube minus b cube equals to a minus b whole cube plus 3ab into a minus b. This one also you have to memorize. All the boxes you have to memorize. This is identities for a cube minus b cube. Did you get it? Okay. So how to memorize these two? See, in the case of a cube plus b cube, we have to start from plus. So a plus b whole cube, since we have used here plus, so this will be negative. So a plus b whole cube minus 3ab into a plus b. Okay, and for minus, the first one is minus, and for this minus it is plus, and after that minus. Okay, thoroughly you have to memorize so that you can solve each and every problem of the second exercise. Did you get it? Okay, so now we have 4 identities. What? The first one identities I am marking. You have to note down all these things and memorize thoroughly this one. And we have derived another form of this line, and for this one also, one more identity. Okay, so you have to note down all these things. Now, we will solve some problem on the basis of these 4 identities. Okay, from the book ICSE Mathematics by D.K. Bhattacharya. Okay, example 1 equals to what? We need here the identities for a plus b whole cube. So just to remind, a plus b whole cube equals to what? A cube plus 3a square b plus 3ab square plus b cube. So just apply this. So here a means 3x and b means 2y. So a cube means 3x whole cube plus 3a square b. A means here 3x square, b means 2y plus 3ab square. 3a and b square will be b means here 2y. So 2y square plus b cube, that means 2y whole cube. Now simplify. 3 cube means 27 and x cube plus 3 square means 9, 9 to the 18, 18 to 3, 54. 54 x square y. You can simplify according to your knowledge. Okay. 2 square 4, 3 4 is 12, 3 12, 36. X y square plus 8y cube. This completes the first solution. Understood? Next. 6th number problem. Okay, 6th number problem I will solve. 6th number problem is given that okay, let me solve these two first. Okay, see the first one. For the first one, 6 number problem, here x cube plus 1 by x cube, you have to compute. You have to compute the value of x cube plus 1 x cube minus 1 by x cube, and x minus 1 by x is given. Okay, so if we take x as a and 1 by x as b, then a minus b is given, and you have to compute a cube minus b cube. So we need here the identities for a cube minus b cube. Just reminded the identities for a cube minus b cube. I am writing here for your remind you that a cube minus b cube was a minus b whole cube plus 3ab into a minus b. So we have to use this one. So write down given x minus 1 by x equals to a. Okay. Now x cube minus 1 by x cube, this can be written as x cube minus 1 by x whole cube. So this is a cube minus b cube. A means here x and b means 1 by x. Okay. So this is nothing but x minus 1 by x, that is a minus b whole cube plus 3ab into a minus b. Okay. So x cancel out. Put the value of x minus 1 by x, a. Then it will be a cube plus 3, this is 1, and x minus a equals to a. So this is 3a. So this complete the solution. Problem number 8. See, in problem number 8, it is given that x plus 1 by x is given, and you have to compute for x cube plus 1 by x cube. So if we take x as a and 1 by x as b, then a plus b is given, and you have to compute a cube plus 1 by a cube plus b cube, since we have taken 1 by x equals to b. So we need here the identities for a cube plus b cube, a cube plus b cube. So write given x plus 1 by x equals to root 3. Now x cube plus 1 by x cube, this is nothing but x whole cube plus 1 by x whole cube. So this is a cube plus b cube, identities for, so a plus b whole cube minus 3ab into a plus b. Put the value x plus 1 by x equals to root 3. So root 3 whole cube minus x cancel out. So this is 3 into root 3. Okay. Now root 3 cube. Root 3 cube means root 3 into root 3 into root 3. So if you multiply 2 times root 3, then it will become only 3 and 1 root 3 left. So ultimately we will get, if we multiply 3 times root 3, then we will get 3 root 3. So this is 3 root 3 minus 3 root 3. So these two terms cancel out, and ultimately answer 0. Okay. So this is the solution of 8 number problem. Understood? So I have solved 6 number and 8 number problem. 9 number problem you can solve. 10 number problem also same as our 6 number problem. So 9, 10 similar problem you can solve by yourself. Okay. 11 number problem, 12 number problem. Okay. 11 number problem and this 8 number problem same, exactly same. Here given that x plus 1 by x whole square equals to 3, so x plus 1 by x will be root 3. Okay. After the same problem, next 12 number problem I will solve. 12 number, 12 and 13. Okay. 12 and 13 I will solve. 12 and 13. Okay. So let me write the question. See 12 number problem. Evaluate 8a cube minus 1 by 8a cube if 2a minus 1 by 2a equals to r. So 2a minus 1 by 2a is given. Okay, so if we take 2a as a and 1 by 2a as b, then a minus b is given. And see, you have to find out a cube minus 1 by b cube. So you can solve it easily. So given 2a minus 1 by 2a equals to r. Now 8a cube minus 1 by 8a cube equals to, we can write in the place of 8a cube, we can write, we have to express it first into the form a cube, so it can be written as 2a whole cube. That means 8a cube minus 1 by 2a whole cube. So this is our a cube minus b cube. So the formula is a minus b whole cube. Since minus is there, so it will be plus 3ab, 3 into a into b into a minus b, that means 2a minus 1 by 2a. Now put the values. The value of this is r, so it will be r cube. Here 2a cancel out, so plus this plus here 3 into the value of this is r again. So this complete the solution. Hope you understand this thing. Okay, next problem number 13. Problem number 13 is important. Important means not in as usual way. We could not solve this one. Okay, I'm solving now problem number 13. Problem number 13. Given that x square plus 1 by x square, it is given. So write the given x square plus 1 by x square equals to 7. It is given, and you have to find out this x cube plus 1 by x cube. Okay, our target is this and given is this. So first we have to check that to compute x cube plus 1 by x cube, what is our requirement, what we need. Okay, so what is the identities for a cube plus 1 by x cube? This is nothing but a cube plus b cube. Okay, this is nothing but, if we take x as a, then this is a cube plus 1 by x means b cube. A cube plus b cube equals to what? A plus b whole cube minus 3ab into a by b. So here x and x will be cancelled out. So to compute the value of x cube plus 1 by x cube, ultimately we need the value of x plus 1 by x. If we have the value of x plus 1 by x, then easily we can compute the value of x cube plus 1 by x cube. Okay, so our target is now to compute the value of x plus 1 by x. Why? Since we need the value of x plus 1 by x. So we will compute the value of x plus 1 by x from the given. See the given? So this given can be written as x square plus 1 by x whole square equals to 7. So this is of the form a square plus b square. So from a square plus b square, just try to remind, from a square plus b square there are two identities. What? One is for a plus b whole square minus 2ab, and another one is a minus b whole square plus 2ab. So which one will be suitable for here? So we have to compute the value for x plus 1 by x. So first one is suitable. So from x, in the place of x square plus 1 by x square, we can write the identities for a square plus b square is a plus b whole square, a plus b whole square minus 2ab. 2a means x and b means 1 by x equals to 7. Okay. So we have to compute for x plus 1 by x. So here x plus 1 by x whole square. Here x cancel out, it will be minus 2 equals to 7. So this is nothing but x plus 1 by x whole square equals to, consider this 2 in right hand side, then it will be 9. Why? Minus 2, so if you consider in this side, then it will be positive. So 7 plus 2, that means 9. So what is the value of x plus 1 by x? Since square is there, so to remove square, x plus 1 by x, to remove square, there will be square root over 9 equals to 3. Okay, actually plus and minus should be there. So if we put here the value, then 3 cube, if we take 3 cube minus 3 into x plus 1 by x equals to 3. Equals to 3 cube means 27 minus 9 equals to 18. Okay, this completes the solution. Note down. (14, 15 and 16). I will solve these problems. Rest all the problems I think you are able to solve. Okay. So before solving these problems 14, 15 and 16, I would like to explain a theory for you. Okay. Now the important result, one result, you have to memorize it. Okay, I am proving and you will memorize. Actually, we are going to prove that a cube plus b cube plus c cube minus 3abc equals to a plus b plus c into a square plus b square plus c square minus ab minus bc minus ac. Now we have to prove this result. Okay, we have to prove it that this equals to this. Okay, actually this is term and this is called factorized form of this algebraic expression. Factorized form, why? Since this is in multiplicative form. Let's see the first factor into second factor. Okay, now you have to prove it. So I am considering the first one, first line. Proof. A cube plus b cube plus c cube minus 3abc will be there. Okay, 3abc equals to, first we will use the identities for a cube plus b cube. Okay, so a cube plus b cube equals to what? A plus b whole cube minus 3ab into a plus b. So we can write this part in the place of a cube plus b cube. So up to this simplified done. So plus c cube is there. So write here plus c cube and keep it unchanged. Rest all the terms keep unchanged. ABC. Next. Again we will consider this term and this term. Okay. A plus b whole cube plus c cube. We make the group and rest this term 3ab into a plus b minus 3abc. This. Just this term is here, this term here, and 3abc is here. Okay. Now again, if we use repeated times, if we consider a plus b as a single a, then this is a cube plus b cube. Okay, and identities for a cube plus b cube is what? A plus b whole cube. That means a means our a plus b. Okay, so this is our first one, plus b whole cube minus 3abc. 3abc means 3 into, this is our A and this is our C, okay, into A plus B. Here A means A plus B and B means C. AQ, just we are using here AQ plus BQ, so it will be A plus B plus C again. Now rest two terms are, this is one term and this another term. So from these two terms we can take common 3ab. See, 3ab is common in both, so we can take common minus 3ab. So if we take common minus 3ab, then minus 3ab already taken common, so rest term is a plus b, and for the second term 3ab already taken common, so only c. Since we have taken minus common, so it will be plus, so plus c. Now look at the board very carefully. How many terms are there? 3 terms. First term minus, second term minus, third term. And in these 3 terms there is a plus b plus c common. So we can take common among all these 3 terms. So if we take common a plus b plus c common, then a plus b plus c, then what will be left in first term? There is q, and we have taken a plus b plus c, so 2 times a plus b plus c will be there. So this is nothing but a plus b plus c whole square. Okay, here will be 3c into a plus b for second term. A plus b plus c taken common, and c I have considered just here 3c into a plus b, and for the last one 3ab will be left. This, so keep it unchanged, a plus b plus c. Next simplify this only within second bracket, the part of second bracket. So a plus b plus c, direct formula, a plus b plus c equals to a square plus b square plus c square minus 2ab, sorry, plus 2ab plus 2bc plus 2ac. So this complete the identities for a plus b plus c whole square. After that 3c into this, so expand it, so it will be 3. If you multiply with this, then first one will be minus 3ac plus minus minus 3bc, so minus 3ac minus 3bc. This up to this complete. After that minus 3ab. Next, implies that a plus b plus c into a square plus b square plus c square. Here like terms are 2ab and there is 3ab minus 3ab. These two are like terms. So plus 2ab minus 3ab means minus ab. Similarly bc and bc, this bc and this bc. So it will be minus bc. And for AC you will get minus AC. So this complete the proof. See, a cube plus b cube plus c cube minus 3abc equals to a plus b plus c into a square plus b square plus c square minus ab minus bc minus ac. And this is the very important identities in this chapter. Okay, and you have to memorize it. Is it clear? And what? A plus a cube plus b cube plus c cube minus 3abc equals to a plus b plus c into a square plus b square plus c square minus ab minus bc minus ac. Okay, now case 1. Sorry, note 1, write it in note. Note 1, if a equals to b equals to, sorry, if a plus b plus c equals to 0, then what will happen? What we can conclude from here? If a plus b plus c equals to 0 anyhow, then this term 0, 0 means what? 0 into this means entire right hand side part equals to 0. So if a plus b plus c equals to 0, then a cube plus b cube plus c cube minus 3abc, the value of this will come 0. So this is nothing but a cube plus b cube plus c cube equals to 3abc. Just we have considered the term this in another side. Okay, so this is the important note. With these identities, if we put or anyhow in any case, if a plus b plus c equals to 0, then a cube plus b cube plus c cube, it will be identical with 3abc. Understood? This is a very important result. Okay, next. Hope you understand all this thing and note down all this important information. Find a cube plus b cube plus c cube minus, solve. Given that, find a cube plus b cube plus c cube minus 3abc by ab bc plus ac minus a square minus b square minus c square, and the value is given abc. This is the problem. Okay, since value of a, b and c individually value are given, so you can put here directly. Okay, then you will get the answer, but it will be very complicated and it will be very large also. That's why we can use a small trick. That one is the way you can solve by that way. If you put here a equals to minus 5, b equals to minus 6 and c equal to 10, then you can get the value. But we will use a trick. Since a cube plus b cube plus c cube minus 3abc, we will know the identities for this one. So solution. Okay. A cube plus b cube plus c cube minus 3abc by ab plus bc plus ac minus a square minus b square minus c square. We know the identities for the numerator, a cube plus b cube plus c cube minus 3abc. What is the identities? That a plus b plus c into, just I have discussed, a square plus b square plus c square minus ab minus bc minus ac by, now look into the denominator. Here denominator looks like this term. Okay, just if we take common minus 1 from the denominator, so I am taking common minus 1, that means taking common minus, then all the sign will be changed. So I am arranging. Okay, so minus a square will be plus a square, all plus will be minus and all minus will be plus if we take minus 1. So it will be a square plus b square plus c square. Since they are of negative, after that ab, bc, ac, these are positive. So since we have taken minus common, so it will be negative. So minus ab minus bc minus ac. So where did so we get some advantage. How? This term and this term will be cancelled out. See, this term and this term. So ultimately this minus and this a plus b plus c, this is nothing but minus of a plus b plus c. My minus was there, I have considered. Now put the value. Minus of a equals to minus 5, b equals to minus 6 and c equals to 10. So this is nothing but minus of minus 1 equals to 1. This completes the solution. Understood? Next, problem number 15. Note down this solution. Okay. So to solve the first one, See, a square plus b square plus c square is given and ab plus bc plus ac also given. So we know the identities. We know the identities for a square plus b square plus c square. What? That a square plus b square plus c square equals to a plus b plus c whole square minus 2ab minus 2bc minus 2ac. This. Okay. We know the identities. So if we take common here, first put the values. What is given? And a square plus b plus this 50 is given. Where our target is to compute a plus b plus c. So keep it unchanged. And if we take common minus from the here, then it will become ab minus bc minus ab plus bc plus ac. So you put the value of ab plus bc plus ac, then it will become 50 equals to a plus b plus c whole square minus 2 into the value of this is 47. So 47 into 2. 47 into 2 means 94. 94. Okay. Therefore, our target is this. So I have to consider all the terms in another side. So I am writing in reverse way. Okay. So a plus b plus c whole square equals to 144. Therefore, a plus b plus c equals to plus minus 12. Just we have to consider square root. And square root of 144 means 12. Okay. So this is the first one. First one is done. Now to solve second one, okay, we are using here the positive value only. Okay, it will be better. Okay. Now we have to compute for a cube plus b cube plus c cube minus 3abc. So we know the identities for a cube plus b cube plus c cube minus 3abc. We will apply there only. You have to put all the values, then you will get the answer. Okay, I am solving the second one. So I am for second one. We know a cube plus b cube plus c cube minus 3abc equals to a plus b plus c into a square plus b square minus plus c square minus ab minus bc minus ac. Okay, so put the value what you have. A plus b plus c equals 12 into value of a square plus b square plus c square, what? Given that 50. And now take common minus from this last term. We have put the value of a square plus b square plus c square 15, and if we take common minus, then it will be ab plus bc plus ac. Now put the value of ab plus bc plus ac, 12 into 50 minus value of ab plus bc 47. So 50 minus 47 means 3. So 3 into 12, 36. This complete the solution. Problem number 15 done. Problem 15 number problem is same as in the end of the exercise problem number 32 and problem number 33. Okay, these two problems are similar. Okay, so you can solve by yourself. Next I will solve problem number 16. Okay. Okay. Here given that a cube plus b cube plus c cube equals to 3abc and a plus b plus c equals to 0 given. You have to prove this equals to 3. So I am considering the left hand side. So left hand side b plus c whole square by bc plus c plus a whole square by ac plus a plus b whole square by ab. Now in the place of b plus c we can write, since a plus b plus c equals to 0 given, since a plus b plus c equals to 0, so if we compute from here b plus c, then b plus c will be minus a. See, just consider this time in another side. So b plus c minus a. Similarly, c plus a will be minus b, and a plus b will be minus c. Okay, we will use this concept. So in the place of b plus c, we can write minus a, and minus a square. Minus a square. Okay, minus a square by bc plus c plus a, we can write minus b square by ac, plus in the place of a plus b, minus c square by ab. Okay, the reason is since a plus b plus c equals to 0. Next, this is nothing but a square by bc, this is b square by ac, and third one is c square by ab. Now take LCM, then LCM will be ABC only, ABC. So BC cancel out, then it will become a cube, it will be b cube, and third one will be c cube. Now put the value of a cube plus b cube plus c cube. A cube plus b cube plus c cube means 3abc. So in numerator, in that place it will be 3abc. Just put the value of a cube plus b cube plus c cube, and denominator abc. So ABC cancel out, and the answer is 3. So this complete the proof. Hope you understand. This complete the chapter. So next, in my next class, I will start a new chapter.